Hi, we are the class 3EL of Liceo Linguistico Celio in Rovigo. In this month we have used the CLIL, that means Content and Language Integrated Learning. In this case the content is math and the language is English, to study quadratic functions and their graphs called parabolas. Now we are going to present our project, which includes a PowerPoint and a video where we explain the theory, so how we can sketch a parabola, how to work with quadratic functions, and how to solve real-life problems.
Where can we find parabolas? Parabolas are absolutely everywhere. Wherever you are, there are surely many parabolas surrounding you. These are some of the examples of parabolas in real life. The smile is an example of parabola that opens upward. The Eiffel Tower. The bottom of the Eiffel Tower is a clear example of parabola opening downwards. Bananas. The banana is a parabola opening upwards. We can find parabolas in nature as well, because the waves are parabolas that open downwards. We can also see that parabola has many practical functions. For example, there is a way to cook using the parabola. The headlights of a car use as well the property of the parabola, which permits them to reflect the rays parallel to the x-axis. This every time if the parabola is made of material which reflects light.
Hi, in this video we are showing you what a quadratic graph looks like. Okay, so the standard form of any quadratic graph is y equals ax squared plus bx plus c, where a, b and c are constants and a doesn't equal 0. So we can immediately understand what form the graph will have just by looking at the value of a. So if the value of a is positive, the parabola will be a U-shaped parabola. So in this case it's y equals x squared plus 3, and we can say it that it's U-shaped. But in another case, if the value of a is negative, the parabola will be an N-shaped parabola. So it's y equals minus x squared plus 4, and we can say it that it's N-shaped. So a parabola always have a line of symmetry that is in the middle of the parabola. In the line of symmetry there's the vertex, that is the highest point of the parabola, and we calculate it doing the middle point between the 2 points where the parabola touches the x-axis. So in this case the 2 points are 0 and 2. Then, to calculate the y-coordinate, we can put the middle point through the equation. So the 2 coordinates of the vertex are 1 and 2.
How can we better understand what are the roles of the constants in a quadratic function? Firstly, we can go up to this icon, which is called slider, and determine 3 sliders that we will call A, B, and C. Then we can write here the general form for a quadratic equation. If we move the slider A, we can notice that the shape of the parabola changes. Then, if we move the slider B, there is the change in the position of the axis of symmetry. And finally, if we move the slider C, the intersection with the y-axis will change. Then, we can notice how this can be influenced by the discriminant of the quadratic function. We can select the icon text and write right here the formula of the discriminant, like this. Now we can notice how the values of the discriminant change as we move the sliders.
To sketch the graph of a parabola as a locus with GeoGebra, firstly we have to plot a straight line D called directrix. Then we have to plot a point F which doesn't lie on D called focus. Then we have to plot a point Q on D. Then we have to plot the axis A on the line segment FQ. Then we have to plot the straight line B through Q and perpendicular to D. Then we have to plot the point P intersection of A and B. And finally, we have to plot the locus of P with respect to Q on D. So, given that f of x equals 4 minus 4x minus x squared, where x belongs to R, copy and complete the given table. Then, draw the graph of f of x in the domain of minus 4 less or equals to x less or equals to 2. If the graph represents the temperature in degrees taken every 2 hours between 6 a.m. where x equals minus 5 and 8 p.m. where x equals 2 in a certain city, use the graph to estimate the temperature at 11 a.m., the time when the temperature was highest, the time when temperature was 4 degrees, the number of hours the temperature was at or above freezing point. Then, to find y, we have substituted the values of x in the table, so we have found that. Then, we have solved the equation with completing the square, so we have found minus 3 divided by 2 and 25 divided by 4. So firstly, we have found the two intersections with the x-axis, which turn out to be minus 4 and 1. For the first point, we have done the mean between minus 3 and minus 2, which turn out to be minus 2.5. For the second point, we have done the mean between 12 and 14, which turn out to be 13. For the third point, we have put 4 instead of f of x, so we have found 0 and minus 3, which were 16 p.m. and 10 a.m. Finally, on the last point, we have solved a quadratic inequality, so we have put our function greater or equals to 0, so we have found 10.
Let's solve it. First of all, we have to find the intersection of the parabola with the x-axis, so we put y equals 0. In this way, we solve the function in the usual way and we find the two intersections. Then we have to find the intersection with the y-axis, so we put x equals 0 and we find y equals 7. At the end, we have to find the vertex point, and we notice that in this case we have an N-shaped parabola, so it is the highest point of the parabola, also called the maximum point. To find the x of the vertex, we have two ways. The first, minus b divided by 2a, and the second, we have to add the two intersections with the x-axis and divided them by 2. To find the y of the vertex, we substitute the x in the function.
The second point of the problem asks us what is the height reached after 1.5 seconds. So, if we watch the graph, we can see that 1.5 seconds corresponds on 0.5 on the x-axis. So we simply substitute 0.5 with all the x on the function. So we'll have that the height reached after 1.5 seconds corresponds to 9 meters.
The number of seconds the particle is for 4 meters or more above the ground. To find the number of seconds, we use an inequality where our function is greater or equal 4. So we find the delta, and the two values are x1 is minus 1 divided by 2 and x2 is 3. So the number of seconds are when x is greater or equals minus 1 divided by 2 and x is less or equals 3.
So let's solve the problem. We have the equation which is y equals minus x squared plus 8x. First of all, we have to sketch the parabola. To sketch the parabola, we have to put y equals 0. To find the intersection with the x-axis, our intersections are 0 and 8. Then, if we put x equals 0, we find the intersection with the y-axis, and in this case the intersection is 0. Then, what we do now is to find out the vertex of our parabola. So, what we do is to calculate the midpoint between 0 and 8. So, 0 plus 8 divided by 2, and it becomes 4, which is the x of our vertex. This is x equals 4. Then, if you substitute the value 4 to the equation, we find 16, which is the maximum point. Now, we can notice that the x-axis is the length of the side of the enclosure, and the y-axis is the area. Now, if x equals 2.5, and we substitute it to the equation, we will find 2 points, 2.5, and then we will find, if we substitute it, we can find 13.75. Finally, we can notice a thing, that the maximum area value, which is y, that is 16, it occurs most often when x equals to 4.
And after this presentation, we can say that it was an hard work.
But it's useful because we have learned a new way to study math.
And we have improved our fluency and our language.
And also we've learned more about technology, for example recording programs, and also how to use GeoGebra.